But so I'm going to give a quick overview of what salt does, how salt works, and hopefully give people the right inroads to be able to start using salt if you haven't started already, and to be able to answer questions and help people find out how to get deeper down the rabbit hole. One of the main goals of building salt was to make it very, very easy to use, very, very simplistic of an interface, and very grokkable, very understandable. But with that said, there's a lot that you can do with it after that quick setup is done. And there's a lot more that you can do with it that a lot of companies and a lot of organizations and people are doing with it that I certainly did not imagine at the get-go. Okay. Yay, the slides move, they work. So, a quick overview of what salt is. Now, primarily, salt is a remote execution engine. The core concept of salt is that if you can have high-speed control of all of your systems, then you can stack, cough, cough, that's where the stack comes from, you can stack more functionality on top of that low-level control. And so salt itself is founded on this concept of unified platform control under remote execution, so that we normalize different platforms to different command structures, so that we have remote execution that's fast enough to gather data in line with an application across tens, hundreds, thousands of servers. Also, that it's simple. Again, a very serious goal of salt is that despite the fact that the rabbit hole is deep and that there's a lot going on in there, interfacing with individual components of salt, I've tried to make that as easy as possible and as understandable as possible. Now, the remote execution behind salt. This is founded on ZeroMQ. Now, is anyone in here familiar with ZeroMQ? Okay, all the people who have been using salt know about ZeroMQ. Now, is anyone in here familiar with AMQP, RabbitMQ, ActiveMQ, OpenMQ? I've got a few more nods, not very many hands going up. So a few years ago, some banks got together, and some large software companies like Microsoft and Red Hat and others got together, and they said, why don't we collaborate and build a protocol that allows for high-speed network message passing? And so they did. And they hired a guy named Peter Hitchens, and he helped them architect the AMQP protocol. And then they kept going with it beyond what he wanted to do, and made it very, very powerful, but also rather complex. Peter Hitchens, feeling jaded by this, and as you can guess, if you get a lot of banks in one room and a lot of large software companies in one room, and they start making software, just start imagining what that software is probably going to look like. And that's what AMQP is. So Peter Hitchens left and said, I think that it should be simplistic. AMQP works by setting up a middleware broker that everybody communicates through. And Peter said, no, I'm going to make an API so that anybody can just build this functionality into an application. Now, I discovered ZeroMQ the beginning of last year and realized that I could make what I've been trying to make, which was high-speed parallel remote execution fast enough to do real-world tasks. I realized that I can do that with ZeroMQ. And so I started writing salt. But fundamentally, ZeroMQ is a networking library that allows you to do some pretty fantastic things over the network that you can't do with normal sockets. If you're interested more in ZeroMQ, I've given a couple of talks on it in the past, and there's quite a bit online if you just Google ZeroMQ. Okay. Now, setting up and installing salt is straightforward. We have packages available for in an Ubuntu PPA, for Ubuntu and Debian and a PPA. We are inside of Fedora and EPEL for Red Hat based platforms. Thank you, Clint. Thanks to Krista over there, we are in the FreeBSD ports tree. We're in the Arch Linux AUR. Am I missing any? We got Debian, Red Hat, Fedora, Ubuntu, Arch, FreeBSD. We don't have SUSE packages yet. If anyone in here is SUSE guy, then, well, they could, yeah. Okay. So generally you can apt install, yum install, pacman-as, all these things to get salt. But salt is just a Python setup.py. So there's a couple of dependencies that you need. You need ZermQ, you need PyZermQ, some crypto libraries. But you can basically pip install salt and that works as well, or just Python install if you download the source directly. Once it's set up, there's little to no configuration is required. Now I'm going to walk through the config file a little bit if we have time. I'm going to talk about how it is very configurable, but you certainly don't need to configure anything to get it going. And most installs I've looked at haven't needed to configure anything, even in the performance tuning realms. The guys that are, so for instance, a large Ivy League school is using Salt on one of their supercomputers, and I don't think that they've made any modifications to the base config, despite the fact that it's a rather large installation. Okay. Now, I'm going to go over a couple of concepts that we use in Salt. I'm going to run through them very quickly. Right now, SaltStack, the company that I've got, has actually got a 3-day training that covers a lot more than this. So there's a lot in there that we could talk about. But so we're going to start out by getting to know how remote execution works. Now, fundamentally, when you're running with Salt remote execution, the command is that you start off, you invoke Salt, you give a target to say what minions or what systems you want to run whatever you're about to run on, and then you call the module and the function and the arguments that go into that module. And then all of any Salt minion that's attached to the master that matches this guy is going to execute this module. Now Joseph Hall, right after this, is going to talk in depth about how these modules work and how to write them, because they're really easy, and over the last 4 months we've gotten about 50 of them from the community. Okay. But so this is the basic structure and the basic things that are important to be aware of, and that is that we're calling a module and a function, we're passing arguments, we need to know what a target construct is so that we know how to specify what minions are going to run the command, and that's enough to get going. That's the equivalent of, I can use Vim now because I know about escape :WQ. Now, yeah, that is kind of the backbone. All right, this target declaration right here, by default it takes a glob. A glob being how you would normally match a string on the command line for the file system. So an asterisk, any globular structures. We can also pass on that command a capital E to say take a regular expression. We can also pass an explicit comma delimited list, or we can do something called grain matching. Grains are system properties that all of the Salt minions are aware of. So basically we can match these systems based on very finite pieces of information as to who they are and what their system properties are, or just based on their names. And it's on my next slide. And I will now do a demonstration of that. So, I don't think I had time to spin up my salt guys here. No? So what I'm going to start by doing is start a salt master as a daemon with a -D, so it's running in the background there. We can see it spins up a number of processes. It's got a few management processes and then a configurable number of workers. Next, since I want to be able to demonstrate that salt can communicate with lots of different systems, and unfortunately, the server that I use at home just had a drive failure last night. So I can't log into my test environment there, but I can simulate an environment right here on my laptop. This is a great new test that we just added to Salt called the Minion Swarm. It allows you to spin up a bunch of minions locally so you can see what it's going to act like with, say, 50 or 100 minions without actually having to go out and get 50 or 100 pieces of computer hardware. Great way to find scaling bugs. So we say we're going to spin up 50 minions. I'm going to start them so that they all run in the foreground. It's going to be kind of messy on this screen. And they're going to connect to a master on localhost that we set up just over here. Now as all of these minions start up and my laptop gets warm, they're all going to generate all of their RSA keys, so all of their authentication information. And then the master here already has a lot in there, so I need to clean them out. It's going to start grabbing these keys. I've set this master up to auto accept to make it easier. Normally when these guys hook in, you've got to say salt key -A to accept and then follow with a minion ID. Since these are generic test minions, they all have randomly created names. But we hop over here. Yeah, it looks like they're all done starting up, so that's 50 minions. We've got a bunch of keys in here. Wonderful. Good. So I communicated with 50 minions, sent them a command, test.ping. And it was fairly fast. Okay, so about half a second. Oh, that was slow. Stupid laptop is slow. Okay. And then we can actually see all the minions doing their fun stuff over here. Go. So yes, that was 50 minions acting. It's hard to catch. All right. So this target construct here, in this case we're saying everybody, but we could very well say capital G and return all the minions that are running in ArchOS. Or we can say, instead of just ping them, find out what all of their grains are so we know what system properties we can match against. And so we see that, sorry, what?
How long did that take?
Usually, that was 1.2 seconds. Yeah, this laptop's slow, I know. I've got a nice server at home with 24 gigs of RAM, and when I'm running a master on it, this takes closer to about 0.4 seconds. That's more in the acceptable range, I think. But so we see that our grain system, and again, I'm going over this stuff really quick. I'm going to mention a lot of things quickly, say what they are, just so that you kind of wet your whistle and know that they're out there, because there just isn't enough time. But these grains in here, we see what version we're running, we see what we've got a server ID, we see they're all running on physical hardware, what their operating system is. I've got 4 CPUs in this laptop, 8 gigs of RAM, what its name is, etc. And so we can use all these to match with grains. And so we see right here that we're matching OS Arch, OS Arch. Okay? All right. The next thing I want to light on quickly is state management. So what I was just showing you is remote execution. It's fast. We're talking to 50 guys at once. Now, state management. This allows us to do a full configuration management system. So this is similar to what you can get with a system like Puppet, Chef, or CF Engine. Now, some of the differences, some of the design goals of states are that they're very, very fast. So, for instance, and I'm going to show you this in a second, although, to my embarrassment, while I was preparing this, I found a bug in the printout. So the printout won't look right because I hadn't tried this particular stress test yet. I'm deeply embarrassed. I'll have that fixed in the next release. But so states are very, very fast. They're declarative states, so they're a little more like Puppet in that you declare how your systems are going to be set up, and then they're set up that way. They're always run in the same order, and ordering is very easy to do, so it's completely predictable, completely finite. And states are also made in such a way that they are as easy to write as I could come up with. And they can also be written in many different formats. By default, we write all of our states, and those of you who were in Carmony's talk yesterday, which was fantastic, he gave some demonstrations of how to write states. I'm going to go over a few if we've got time. Actually, we'll go over a few right now. But states are declared in a data structure. And SALT doesn't really care how it gets that data structure. By default, it wants it in YAML, because frankly, YAML's pretty darn readable. But if you've got a problem with YAML and want to use something else, then SALT can do that. You can write them in pure Python, you can write them in JSON, and right now what's supported is YAML, pure Python, and JSON. But if you wanted to build a module that allows you to write them in XML, you could. You could write them in Ruby, you could write them in Perl if you wanted to build a system that handled that. Okay? They've also been made to be very, very easy to extend. I think that if we're lucky, Joseph is going to get far enough with his talk that we'll talk about how to make new states. So, we've done some basic remote execution, but now let's take a look at a state tree. Now this state tree I'm using, I'll use small, it's prettier, is available up on SaltStack's GitHub organization page under the repository name is Salt States. Well, so how states work is we define a top file, which is a map, which says these states need to be applied to any system which matches this value. And so, if we come up here, we see that we've got some globs. Anything that matches these globs here, HAProxy, Mongo, Syndic, WebServe, is going to install these salt states. And then, since we can match with more than just a glob, right? We can use regexes or lists or grains. We've got down here, this is going to be a grain, and this is for all of our Red Hat systems. This is all of our FreeBSD systems. So that allows you to get a little more granular with how you're defining who's going to execute what. Salt is also environment-based. I'm only going to be showing a single environment setup in here. But the default environment is named base. but we can create as many environments as we'd like, so that we can have production and development and all these sorts of things and move the code through it. We can also define what environment the minions that we're talking to are connecting to from the master, so that we don't have to configure our configuration management system for it to configure the system. If you want to, though, you can statically define an environment from a minion. But if it matches inside of an environment, then that's the one it's going to be using for those components it matches under. So, if we look up here, we've got one of these guys called Apache. So I'm in the root of a state tree, and we see that there's a directory there called Apache. If there is an Apache SLS module in there, as we call them, then it's going to be named init.sls. And there it is. We can open this guy and take a quick look at what one of these look like. So, we've got up top as a name, Apache. This name is now the name variable that's applied to everything that's declared underneath it. So we don't have to say Apache again, per se. And then we're able to say it's going to be a package. We're going to make sure it's installed in a service, make sure it's running. The service's name isn't Apache, so we're going to overwrite that by saying it's HTTPD. And we're also going to say that if running on a Red Hat system, that the name is HTTPD for the package. So in here we're saying that we're using YAML, but we've also got the Jinja templating language. Now let me find one that's got a little more in it here, or a little less. There we go. This one doesn't have any Jinja, so it should be a little more straightforward. But so we're saying HA proxy, make sure that the HA proxy package is installed, make sure the service is running. Don't try and make sure the service is running until after we've verified that HA proxy is installed. That's what our require statement is there. We've got a file in there. We want to make sure that it's managed and make sure that the name of the file or the location where we're putting it, it's the HA proxy, haproxy.conf, and that's where we're going to find the file. So, there should be, what was it called, haproxy.cfg. When we use this SALT protocol, we're using the SALT file server to specify that it's going to be in the HA proxy directory, and it's going to be called haproxy.cfg. So I'm going to make it, because it's not there. If it's not there, then the minion will throw an error, and we'll see that in the state output that says couldn't find the file in the master. See, I'm a Vim master. I just typed escape : WQ. Okay. So we can see that HA proxy module is referencing that HA proxy file. So, states, hopefully they're very simple to set up. A lot of guys have come back to me and said that they were able to set up very, very large salt state trees in a matter of sometimes days, sometimes just a few weeks. I've had companies come back that have been using some other configuration management tools and said, well, it took us 1.5 years to develop our tree in Config Management Tool X, and we had it moved over to SALT in 3 weeks. That is a very common thing for us to hear And then I get quite a few personal emails that say, wow, thank you. Our tree is, our config management is no longer difficult. It just works. Okay? Now, there's a couple philosophies that we've got with salt states, and I'm actually going to take a look at some salt states and compare them inside of our file here to help understand how they work with what the actual code looks like. The mapping is very, very straightforward. But so let me explain it again really quick. We've got HA proxy, that's called the ID declaration. PKG is a state declaration. Installed is a function. So, and then under file, we've got file, it's a state declaration. Management, it's a function. Managed, it's a function. Name and source are arguments. Wow, some of these terms probably sound rather familiar to people who have ever done programming of any type, like functions and arguments. So, let's look up some functions and arguments. So if we go over and take a look at the salt source, what? PyRender broken. I'm gonna have to verify that bug. Yeah, that's an old bug. I gotta get on that. I've been giving a presentation. That's why that bug got to 22 minutes old. All right. So this is the base of the salt source code. We come over here to states, and which one we're looking at? Okay, let's look at PKG. When I called PKG, I say installed. And there's installed, it's a function. Effectively, we're calling this function inside of the state module. When I said PKG, I'm referencing the fact that I'm calling the PKG state module. When I say name, there it is. Every state function, the first argument has to be name to accept the name. And then we've got a number of arguments that we can pass into it. And so Salt, by the nature of its code, is self-documenting, not to mention our wonderful doc strings. So the actual act of writing a state is extremely straightforward. This is just a Python module. And so if we go look at, this one's fairly simple here. If we go look at file, which is a little hairier, file management is, believe it or not, it can get kind of complicated. Inside these modules, if there's an underscore in front of them, they don't get called, but Joseph will give you more on that in the next presentation. But we can come through this guy, underscores, file's kind of complicated. There we go. And start looking at functions that are available. These are all documented on the docs website. I'm just trying to illustrate how the data passes through. But so we see there's a function, it's called symlink in the file module. So if we wanted to make a symlink, we'd do the path to the symlink, which is the name, colon, file, colon, dash, symlink, and then fill in the arguments. And that's it. And then this function makes sure that that happens correctly. Every one of these state functions then returns a data structure that looks like this, that has these 4 fields in it, so that we can make determinations as to was it successful, yes or no, or none if nothing was executed for the result field. Changes, it gives us a list of everything that it changed so that we've got that list. We know the name of what it is that was affected, and then hopefully the comments are helpful. If you don't feel a comment that you receive in one of these outputs is helpful, feel free to file a bug. I might No, I'm usually cool about those. Okay. But so again, that's the goal. Very simple translation over code. That translation over the code makes it easy to write more states, which is why, what are we at now? Which is why we have this many states, and 4 months ago, how many did we have, Krister? We had what, like, who am I kidding? I can look it up. So not as many. Okay. No, whoop, I want that one. Now, similarly, when we were calling that command line function, okay, we're calling test.ping, right? So what is test.ping? It's this. Yeah, we're not pinging. There's no ICMP. Right, we're calling a function. And so we go into the modules directory. We have more of those. There we go. We can look up the test module, which is, what am I blind? There it is. And it has a function called ping that returns true. It's kind of straightforward. It didn't take me very long to write this one. Okay. So did somebody just say I could write those? You probably can. That was the idea. And that's why we have this many of them. I sure as heck didn't write all these. Especially not these Windows ones. Wow. Yeah, I can't tell you how much I appreciate Dave Boucher for writing all the Windows support. All right. Next, we were talking about one of these. The fact that we don't have to write this in YAML, right? We do that with another kind of module called a renderer. It's this folder. And so we can see that writing a renderer is not too particularly complicated in and of itself. We just have to make a render function.
Apparently this one's broken.
Yeah, apparently. I mean, I tested it before I put out the last release. Okay, I'll have to read that bug. I'm sure someone here has already read the bug and they're chuckling to themselves. Okay, but this allows us to take an SLS file, and as long as it's spitting a data structure out that conforms to the data structure specification, Salt's happy. So that's all it takes to be able to write SLS files in something other than YAML and Jinja, if you don't like YAML and Jinja. What was that mumbling? All right. Where am I trying to get to? There we go. Okay. So, a couple things to think about when you're writing salt states. That the state data is always compiled on the minion. Now, this isn't a big deal because the compiler is very, very fast. I'll demonstrate here in a minute compiling the state tree for those 50 minions on my laptop and let you all see how long it takes for that to return. For 50 of them. Now, the execution is always deterministic. It always executes the states in the same order so that you can get a very clear idea as to when they're running, and then when they're done running, they display in the order well, as of 9.8, they display in the order that they executed in. There's no event loop. So some of the other guys out there, they create an event loop and they're firing events back and forth. I felt that that was too heavy of an operation, as well as less deterministic. So in SALT, we predefine what order everything is supposed to go in by reading all of the relationships in and then executing in that order. You can also pass a global argument in, an argument that works on any state called order, and give them a finite number as to this is going to be the fifth one that's going to run. Okay, and it's been engineered to be fast. I've put a lot of effort into making sure this SALT is as fast as possible, making sure the network overhead is as low as possible, and making sure that algorithms aren't incredibly horrible. I'll admit there's a few hairy ones. All right. To get the master ready to actually execute states, there's one configuration option you need to modify. By default, states are on and available if you just start building out one of these state trees under /srv/salt. If you don't want it under /srv/salt, or you want to build environments or build dependents, what's that called? Or I should say, what's a good way to call it? Okay. Then you come into the master config file and you declare the file roots option. So we say file roots, base is an environment. We can make as many environments as we want. And then we list in a search order what directories are going to contain this tree inside of the base environment. So we could declare a bunch of directories, and then it's going to search those directories in the order in which they're declared in the configuration for the files or the SLS files or just the plain old files that SALT's trying to download. Now the benefit of this list here, and I've actually been really surprised how many people have used this because I made it by accident. The benefit of this list here is that a lot of people have this base directory of states where they've got their base environment and they've got things that are shared across all environments. And then they've only got changes in higher level directories that are higher up on the list. So they put a change in that higher level directory, don't change the base directory, and they can just pull it in and out very seamlessly. But that's all you have to do for states. Start a master and make sure that it says the file roots go somewhere. And then put states in that directory, and you're done. Any questions, arguments, concerns, rebuttals? Well, you're easy. And that actually worries me a great deal. Okay. Now, when you're putting together a state tree, it should be very simplistic. Again, the simple design. As soon as you make things more complicated, that's when you lose track of how things are happening. So putting a top file, that top.sls file, which is your map, stick that in the root, and then try and make it shallow but broad, so that you have lots of directories filled with SLS files instead of doing a lot of deeper stuff is usually a safer way to do it. Yes?
I just have a question. About the last slide you had of this different hierarchies. Is that only for files now? It doesn't really make sense for packages. If you wanted something like dev to be, I don't know, a package or version. It doesn't really work with that file overriding thing.
Yes.
You have a different group. How do you do that?
Okay. So if you wanted to have a different environment, say you've got a dev environment, and you want a different package version in that dev environment, then you can declare version equals as an option inside of package, and it'll just go get that particular version inside the SLS. Another common way that guys do that is they actually put all of their packages into versioned repositories that follow environments. But Yes, it can do that. Unless I completely misunderstood your question. Okay. Now, how long do I have till? 6? Oh, rubbish. States are awesome. Moving on. Okay, there is a little bit of jargon in here, which might get a little confusing for states. One of the design principles of SALT is that I have tried to abstract all of the levels of management so that they're visible. Just because they're visible, it doesn't mean you need to know them all. Inside of states, if you know what a high state is, then you're probably good to go. High state means that we're going to look up that top file, we're going to declare what's in it, and do what's in that top file, and we're done. And that's it. There's your escape : WQ. Now, there are a number of different layers, so we can go down the compiler stack for SALT. We can send data in that's in the middle of the compiler, at the bottom of the compiler. We can say, I don't want to use high state. I want to tell my guy to just directly grab this individual SLS or this list of SLSs so that I'm declaring on the minion side exactly what's going to be installed. I could say, I don't want a top file at all, and I'm always going to execute by grabbing an explicit list of SLS files. So there's a lot of different things you can do by moving down that pipe. Okay. Now I started to get into this a little bit as to what's under the hood with SALT and where the real plug-in modification capabilities are. Now I'm going to start by talking a little more about those modules. I opened one up. It's just a Python module. And again, Joseph's next talk is going to talk more about how to write those and how those work. But with modules, all we have is module name dot function. That's how we call them. If you want to make a new module to extend the existing modules in SALT, all you've got to do is shove them in with the rest of the modules and it'll just work. Grains, I showed the output of grains. Now grains are always meant to be static system data. Now the reason for this is I wanted to be able to match against system data very, very quickly. And so when the minion starts up, it runs grains and collects this static data. If we go back and look at these guys, I hope I run them all. I'm sorry I wasted a second of your time. If we go back and look at these guys, we can see that we have total memory, but we don't have used memory. All of these values are pretty darn static. It's going to be hard to change the kernel without rebooting this system. If you want dynamic data, you always call that from a module. So grains should always be static data that is specific to the system that's running. Renderers, we talked about those briefly. Those are the things that allow us to take those SLS files and render them down into a data structure so that the SALT compiler can deal with them. Yes?
I'm sorry, you were talking about states and how or grains and how they're static.
Uh-huh.
If you wanted the used memory like you were talking about, was that a state?
No. If you want the used memory, then you'd run there's a module that you can check or that you can run that gathers that data. So grains are static, modules are primarily dynamic or work-based. And grains should never modify anything on a system. They should only be looking up static system data, whereas modules modify things and check things that are dynamic. So there's I think it's status.meminfo is the module and function that would return that. Okay, you happy? Okay. We mentioned renderers. Now returners. Well, how SALT executes is primarily detached. So it would be kind of a pain if we said to everybody in parallel, execute this, and then we're going to hold on to those connections and wait for all this return data to come. So we publish the data out, and then we just hang out and wait for it to get redirected to a different port on the master for it to be returned. Now, because the execution of this data is fundamentally detached, it doesn't have to return to the master. We can have it return to any arbitrary interface, program, database, whatever. And so if we take a look at that, returners. We've only got a few so far. Our good friends at Jive Communications gave us the Cassandra returner, but we're able to say, no, when I execute a command, I want to redirect this particular command to send its return data back to a database so that I can then shoot out a bunch of commands and cache them. And so similarly, we've got one for Redis and one for Mongo. Now, runners, okay, runners allow us to do convenience operations on the master. So, let's say I'm going to run a command. There we go. I'm going to run a very, very heavy command, which I mentioned earlier, that's going to break my outputter, so that the text output is going to be inaccurate for this command. And again, I'll get that fixed. I'm sorry about that. Because it's a very intense command. When I execute it, I've got a -v there to say solved verbose, so it's going to print out the job ID. Every execution that you run has a job ID. Wow, that was bad. So now I can say, I want you to look up the return data because my output printer broke, obviously. So we need to retroactively look up the fact that all of those 50 minions were able to compile their states and return them cleanly. And we're able to actually see the raw data structure of all of them. Let's see, have I gotten to the top of one yet? Well, the buffers should be full, yeah. And so we were able to illustrate salt run because we can do a few things with jobs. We can do a few things with checking to see what systems are down, so what minions are no longer responding. And we can also, let's see, we've also got a wake on land feature inside of there so that you can send a wake on land packets out to minions that are down. So some master side operations. We're also able to show that frankly, that's 50 nodes that compiled their entire configuration management run. That's pretty quick. If you're familiar with some other tools. All right, and I've talked a lot about states.
Question.
Yes?
How long does the job hang around to be able to query it?
Okay, that's in the master's config file. And it is, there we go, keep jobs. And it defaults to 24 hours. Now I've run into a few guys. We actually found a bug that if you did more than 32,000 jobs in a 24-hour period, that would overflow our job cache and break ext3. So we fixed that so that they're hashed now. But if you're running a lot of jobs on a regular basis, it wouldn't be a bad idea to lower that number. Okay. Now, Salt can be extended very, very easily. Again, this is why, I mean, I see a guy pop up in IRC on a Tuesday and say, hey, I want to learn salt. Salt looks really cool. And I say, well, you're right, it is. You know, let's help you learn salt. And then on Wednesday, he comes in and says, I got my state tree going, and we're managing this and this. It's over on GitHub. And we all look, and I'm proud as can be. You know, he's got like 5 SLS modules up there. He's going. He's getting there. And then I don't hear from him for a week. And the next I hear from him, he's got a pull request on GitHub saying, I wrote a new state for you that manages MySQL databases. Because I've been using Salt for 9 days. Salt really is easy to extend. Actually, another really good example, I was over giving a talk to Jive Communications. Those guys are awesome. And Byron Clark is listening, and he says, hey, I wonder if we could integrate this with our existing deployments setup. How would you do that, Tom? And he presents how their deployment setup gathers some data. And I say, you know, I'd make a custom grain for that. When I'm done presenting, remind me, we'll sit down, I'll show you how it works, and we'll get this custom grain written for you. And I keep presenting. 10 minutes later, Byron says, woohoo, it works! Now granted, that's Byron Clark, so most of us mortals, it'll take at least 25 to 30 minutes. But Salt is really easy to extend. So, I mean, which is what I'm trying to illustrate by saying, this is a returner. That's 61 lines of code. This is, if we look at modules and look at how that install function is handled on the back end for, say, Arch Linux. Where's Pac-Man? There it is. These aren't long, hairy functions that you're never going to understand. That's pretty bad. That's a long function right there. What is that, 30-something lines? 25?
Nearly enough post comprehension. Can't have hairy Python functions without lots of long, hairy functions.
Okay, so what I'm trying to get at is it really is not that hard to extend Salt, which is why, see, come on internets, be fast. If we go look at our stats over on Olo, I love Olo. Despite the fact that we have not been around very long, we've got, that's a lot. We've had 96 people contribute code in the last year. 97 total. Because the project's only 14 months old. Okay. So easy to extend. Now, I've gone over everything rather quickly. And like I've been saying, there's a lot more in there that you can do, but hopefully that's enough information to start getting going. I'm going to finish up by going over where a couple of those documents, where a little bit of the documentation is available, so that you can dive in there. There is a lot of Salt documentation. I've tried to document every feature there. I'm sure that we're missing a few. Now, there's a Salt Stack company, and we've got a training class that makes me money so I can keep writing Salt. Yeah?
Yeah, question. You said you just, if you do want to extend it, you just put a module on that and it just works, but I don't understand how, if you put this module on the master, how will the minion know what that module is, or how to run it, or how it works, or what?
So there's a directory. Now, you remember that file roots directory where we're getting all the states out of, right?
Well, there's files of where the big files are.
Right.
That,
Yeah.
does that modules have the modules in there?
No, the modules are all on the minions themselves, but,
How would you get the modules even? You get
well, Salt does that for you.
Salt does that for you.
Okay. Right, Salt salts itself. So if you make a directory called _modules in the root of this guy
master?
on the master, and then put a module in there, and we can, this is a rather simple module.
It's complicated.
Okay.
Yeah. It's the same place you put your top file. Where it has all your.
Same directory.
Oh, well, there's no doc string on it, so I can't check the doc string. But this module will get populated out. If you want to manually call it to populate out, then we just call
So you supposed to sync with an N?
yes, thank you.
Does this get populated out when the minions register or when the minions have states executed against them?
Didn't get the grains out. I'll have to look into that. When a high state's called, it'll do a sync all. And when the minion starts, they should do a sync all. So that it should be fairly automatic, but if you plop one in there and you want to just push it out, you can do a sync all manually. Yes?
Hey, so when you're like doing different environments like production or testing or whatever, with those grains and module files or directories, do they, so if I put it like in the top one, is it going to then affect the production and the testing and all that, or do I have to put, or can I put like the grain directory in my testing and the grain directory in my
Trying to remember how that works. I don't think I wrote that one down. I need to document that. Hey, Jacob, can you file a bug for me? Thank you. To remind Tom to document how that works and double check how it works so I give you a clear and concise answer.
You got 24 minutes.
I'm 24 minutes. Yes.
So how do you add minions?
So how you just turn them on.
So I have a server.
Mm-hmm.
Let's say Salt doesn't know anything about it. It doesn't know anything about Salt.
Mm-hmm.
How do I then turn it into a minion?
You install the Salt minion on the server. Make sure that the minion, so if we look at the minion config,
That's the only figure required.
which I don't have a copy of on here. Okay. If we look at the minion config, it has this option master. It's going to default to look for a host name Salt. So if you just stick Salt in DNS, you never need to touch this. And all you have to do is turn it on. The minion then says, the master says it's out there. Yeah, it's over there. It generates its RSA keys, shoots an authentication packet over to the master, and the master says, cool, new minion. I'll wait to see if the guy in charge of my master here says that it's okay. So it holds onto that key, and the minion every 10 seconds by default, it's configurable value, checks back in and says, hey, have I been approved yet? So that as soon as it gets approved, it latches right on. So to add a minion, you turn it on. And it adds itself.
And is the name in here also some, ID,
Yes,
yes.
yes, the ID can be statically declared for minions right here, or it's going to use the fully qualified domain name. Yes.
Talk about the Salt files.
Oh, can you use different types of file distribution, like HTTP, FTP, that kind of thing?
Yes, you can. You just type http://
Cool. I probably can't do that, I don't know.
But that's probably why Salt can.
Yeah. The other question there
I really like those.
is, speaking of the salt file server, how scalable is that?
It's been doing a pretty darn good job. I've been able to distribute files. The largest environment I've been able to really play around with to distribute files, and the largest minion swarm I've been able to make is around 900. The only thing that the master doesn't go up as far as using CPU time. I just you can always add more processes to it if it does, because it's got workers. But I've been able to have it download large files, and we're talking gigabytes of files in parallel to hundreds of minions at once, and the master handles it just fine. I mean, it does get slower, because your pipe's only so big, but that's where the bottleneck is. But yeah, so far I've been able to scale it very, very well. There's also an interface that allows for large end scaling. So let's say we've really got 20,000 minions. I don't even want to think about 20,000 minions behind one master by itself. It can do it, and we've been able to test up pretty high, and it doesn't care. But it's just more than I potentially want to logically deal with. So what we can do is create what's called a syndic. So that we've got a master, and it takes care of, say, 200-300 minions, a logical bite-sized group, and then we've got a bunch of other masters, and they're all taken care of. So let's say we've got 15 of these groups, and then we've got another master up here, and we start up a syndic interface that says, I'm going to transparently make this master think that it's directly managing all my minions. So that now we can control all of them together, or we can log into our individual clusters and control them directly. That also helps with scaling, because the main bottlenecks happen when I run that command. I've got hundreds of minions connecting to the master at the same time to return that data. And that's really the main scaling bottleneck. And if we're able to distribute that out a little bit, then that helps with our scaling as well. Although it really hasn't been a problem, because the returns are tiny. ZeroMQ does a really good job of taking care of them and queuing them up. Yes?
So during his talk yesterday, you said you would touch on what salt pillars are. I'm curious.
Sorry, what salt? What are?
Pillars?
Oh, I didn't touch on pillars. And I'm over. That's okay, I know who's talking next. It doesn't say you start till 6.
Sorry to ask so many questions. You mentioned file.recurs. I think there's a recurse option for
Uh-huh.
recursive reads. I mean, everything from here, everything. I probably won't want to go to HTTP.
Yeah, the recurse does require that you use the salt protocol.
The source. How does that compare with rsync? Is it worse or faster than, or how long would it take to say, well, if they're all the same, does it have to run MD5s on everything and go, oh, I guess it's the same like it was 5 seconds ago. I'll try again. I mean, or is it just crush the hard drive while it does MD5 and everything? Does it have some way of...
Okay, when you do a file.recurse, it is going to be running MD5s on files. Now, which means that I wouldn't recommend using file.recurse on a lot of large files. On a lot of small files, I've been able to use file.recurse to successfully and fairly quickly, it takes about 30 seconds to distribute via file.recurse over a fast network, gigabit, the entire Linux kernel source. And so it downloads it and it MD5s all of them. So as long as you're smaller than that, it's not going to take that long. But that is definitely a consideration. That it is going to have to check the validity of those files, because if you've got file.recurse going, and for those of you who are trying to grok what I'm talking about right now, File.recurse is a state like file.managed, but instead of managing a single file, we're saying that this entire this directory and all of its subdirectories on the master, we want that recursively copied to this location on the minions. And when it does this, it's going to go through and compare all of the files all the way down so that you can change one deep file inside of that file.recurse, and that'll get updated on all your minions.
And remove files that shouldn't be there? Like,
Yes.
makes it the same.
Yes. Well, that's if you've got clean equals true set as one of the arguments. Otherwise, it won't. Okay, somebody asked about Pillar. Did he walk out? Oh, no, you're still here. I was looking for... I forgot his name. Dan? Okay, thanks. Sorry, Dan. Okay, pillars. Now, the idea with pillars is that, let's say we want to define a bunch of variables or a bunch of variable data. And we want all the minions to have access to it, but we don't want to define it on every minion. We don't want to put it inside of our SLS files. That's what Pillar is for. So let's say that we're kind of wacky and we've got an environment that has 8 operating systems in it. Say we're NASA. They've got some environments like this. And so every time you declare a package, you've got to have this stanza of, if it's this OS, the package name is this. If it's this OS, the package name is this, right? Well, we can define all that in a pillar. So that pillar is going to give us a variable of that package or of that piece of data. Now, pillar is set up like the state tree. It's got a top file. I'm sorry, I don't have a pillar on me. Otherwise, I'd be showing you. And yes, it's a pillar of salt, Sodom and Gomorrah, Lot's wife. Okay. But so the big benefit of Pillar is that you can define complex data structures once in this pillar. They get compiled on the master. They only get distributed to salt minions that they match. So there's also a security thing there. If you want to put in some passwords that you want only available to certain salt minions, you put them in Pillar. And then, and then you can also do more complicated things. Since Pillar defines data structures, you could define your full SLS data structures inside of Pillar. And then, when it grabs those, you can just realize the full Pillar structures multiple times throughout your SLS files. See, that was the most boring question to answer. I lost like what? Okay. Now I've got Sean and I've got Jacob. Anybody else? And guy whose name I don't know. And another guy whose name I don't know. Since I don't know you guys as well, you go first, because I know these guys. They'll bug me after hours anyway. Yeah.
So our development environment, we specify IPs in the host file so they can, make each other. Is there any way to pass variables in or express that relationship so that this can set that up?
Yeah. There's a state that manages the host file, so that's an option. So you can declare a bunch of IP addresses and names that are associated directly in a host file that way.
Well, I was thinking of, like building up a new environment on, kind of on the fly for testing purposes or whatever.
There's a bunch of guys that have done some stuff with a host file with Salt, and I'm not sure that I completely understand what you're going at.
I think what he's asking is a question that I have too, and that's how do you differentiate which minions are dev, which are test, which are prod?
Oh, you differentiate those either by how you match them in the top file. So if you can match them via grain, or or specify their name to have dev in them and match them that way. Or inside of the minion config file itself, you can say environment equals, and it'll only pull from a certain environment.
We use grains for that.
Yeah, and grains, for instance, we're looking at the minion config. We can statically define a grain in here to match against, or a group of grains as well. Or you can statically define grains that are associated with certain minions inside of Pillar. and then have, or pieces of data inside a pillar, and then match against that data as well. As far as, yeah. Now, was that what you were asking, or were you asking still about populating the host file?
No, but I think, my brain's turning now, so.
Okay. Now, who's the other?
How does the soft protocol handle the encryption? If using the HTTP protocol, is there any security concern?
Oh, if you're using the HTTP protocol to download files in states, yeah, the security's up to however you're handling your HTTP server. And you can use HTTPS.
Okay. For the soft protocol, how we encrypt? How does the soft protocol do the encryption?
The SALT protocol uses the same algorithms for encryption that are used by SSH. So it's fundamentally, we've got an RSA key pairs. Those are used to securely transfer AES keys, and then we use AES to encrypt all transportation data. Okay, I'm almost in on Joseph's time, but we've got Sean.
I think my question was 3/4 answered, so now I'm just down to how do I specify a grain in the minion?
Oh, yes, that's easy. I didn't get to tell you what all these wonderful values are.
Well documented.
They are well documented. I didn't get to go through where the documentation is either. This is a Python project. Some of our test documentation does, or some of our tests do have the script to MontyPython in them. That's it. We've defined a grain. Its name is foo, and its value is bar.
So you can match on that if
Uh-huh.
it's bar star or B star or something like that?
Yep.
He wins.
Okay.
Real quick, can you show us an example of a template? Or is there time? A Ginger template, and what like variables are available to use?
Sure. There probably isn't time. You want to come up here and start getting set up, Joseph?
Yeah. Well, what I found really helpful for me when I was first learning this, I was asking lots of dumb questions every day, is when I discovered that salt state that we have tons and tons and tons of examples. So I kind of just kept going through there and finding all sorts of ways to do things. So, and then if I couldn't find it there, then I'd ask them.
You guys do want to stick around for Joseph's talk. No? Thanks, guys. I'm sorry I went over.